Hey guys, so today I'll be going over some basic Swift stuff again. Starting with single line commenting. So let's say if you have a line of code in Swift and you want to comment it out, it's pretty easy to do. All you do is add 2 forward slash in front of the line of code, and that will comment out that line of code. But let's say you have more than one line of code. So let's say you have line of code 1. Let's say you have a second line of code and you want to comment both of them out instead of doing forward slash twice. What you can do is use multi-line commenting. How you do that is you add a forward slash and an asterisk, and then to close it, so to finish that block of commenting, you can add a asterisk and then forward slash again. That would comment both of these. That would comment everything between these two, indicators, I would say. So yes, what you can do also, if you can have these also nested. So what you would find sometimes is that you have a function that let's say prints something, and let's have it print something. And then what you'd find a lot, people would add like comments, like documentation to their code. So they would say like this function prints something. And let's say you have one more line of code below. Let's say line of code below func. And let's say you want to comment out all of this in Swift. You can just do the same thing, so multi-line commenting. Now the reason I'm pointing this out is because this is nested. They're nested here, so you see there's one opening here and then another opening here, and it closes here and then it closes over here. So what some languages does not support this, so what would happen is they would see the compiler would see this as opening, and this would be just a regular comment and would match up with this one instead of this one below. But with Swift, it's smart enough to know that this one actually belongs with this one and these two belong together. As you see, they're nested, so that's also supported in Swift. In Swift, generally, we don't really use semicolon. So let's say you have a line of code and you want to write another line of code. You just write it like this, right? You don't need semicolons behind each line of code in Swift, but semicolons do exist in Swift. So let's say you have this written, for example, this won't compile, but a way to make it compile is add a semicolon, and it will tell the compiler, okay, this is where that line of code stops, and this is the next code that you should continue looking at. So semicolons do exist, but generally we don't really use them in Swift. We just write it like this. We just write it like this and without any semicolon. But I just wanted to show that it does exist in Swift. So the next thing I want to cover is the different int forms. So usually we would just write an int like this. Normal int, right? But you can also specify what bit form the integer takes. So you can have an 8-bit int. So let's call it int 8. And then you can also have a 16-bit int. You can also have a 32-bit int. But you can also have a 64-bit int. So yeah, like I said, these are just different. This is an 8-bit int, this is a 16-bit int, this is a 32-bit int, and a 64-bit int. And then the normal int. So let me just move this down here. So let's say you are questioning now how much bit is dit int. Well, this depends on the platform. If you're on a 32-bit platform, this will be a 32-bit int. If you're on a 64-bit platform, this will be a 64-bit int. Now you also have unsigned int in Swift. So unsigned int, which just means it cannot store a negative value. So this is a normal unsigned int, which again would take the form of the platform you're on, but you also specify what bits it should use. So a 16-bit or an 8-bit or a 32-bit. You can specify it like this. Yeah, so these are just, they can't store negative value, they're unsigned int. So these are also available in Swift. The next thing I wanted to show is the bounds. So let's say you want to know what is the maximum value the unsigned int can hold. So you can just do this, uint 64 dot max. And then you can also check which is the minimum value it can store. And since this is an unsigned int, that would be a 0. But all of these types support the min and the max attributes. So on all of these int forms have this min and max. So you can just check what is the minimum value they can store and what is the maximum value you can store. Next is the float. Floating value. You have a normal float, but you can also specify the bits form of each of these floats. So let's say you have a 32, but then you can also have a 64-bit float, and then you can also have a 80-bit float. Like so. So 32, 64, 80. Now a normal float, so let's say you just declare a normal float like so. This will be a 32-bit float. So the float that doesn't specify what bit, it will be a 32-bit float. Now you also have double in Swift like so. 0.0, and the double is basically a 64-bit float in Swift. So these two are the same. That's it, guys. That's the video for today. Thanks for watching.